Hey everyone, here's another example from section 3.3. In this example, it wants us to find the limits of this function, x squared over 4 minus 8 over x. I'm going to show you how to find the limits of this function for these four different values on here. Limit as x approaches 0 from the positive side, limit as x approaches 0 from the negative side, and then also the limit as x approaches the cube root of 32, which is going to be kind of different. It's going to take a little work here. And then the limit as x approaches 32. So let's start with the limit as x approaches 0 from the right. Let's plug in 0 squared over 4 minus 8 over 0. And you see we have a problem here. We have 8 divided by 0. So what we need to do is we need to basically figure out, okay, if we're approaching 0 from the right, that means we're approaching 0 from like the values 1, 2, and 3, like we're coming in on the positive side. So what happens if we plug in a number that is really close to 0? So let's plug in something that's like 0.0001 squared over 4 minus, 8 over 0.0001. So we're just checking out this specific value of 0.0001 squared divided by 4. So let's do that one first. And divided by 4, and you get this small number, 2.5 times 10 to the negative 9. So now I'm going to subtract that, and I'm going to say 8 divided by 0.0001. And you'll see I get negative 80,000. Okay, so when I get negative 80,000 by putting in 0.0001, okay, what if I got even closer to 0? So this time, instead of plugging in 0.0001, I'm going to plug in 0.000001, and I'm going to square that, right, just like it says to do there, divide it by 4. I get a smaller number here, and then I'm going to subtract 8 divided by that 0.000001. And all of a sudden I go from negative 80,000 to negative, let's see, that's 1, 2, 3, 4, 5, that's negative 8 million. So by putting in an even smaller number, I'm getting closer to 0, right? By plugging in a smaller number, I'm getting closer to 0. So if I get closer and closer and closer to 0, let's say I use 0.0000000001, this number is going to get infinitely larger. So I basically am getting closer to negative infinity because this number is getting larger and larger and larger. So our limit as x approaches 0 from the right is going to actually equal negative infinity for that reason. So let's use the same kind of concept here as we go through and we look at x equals 0 from the left this time. I'm going to plug in 0 squared over 4 minus 8 over 0. And again, you can see that that's a problem. So let's now plug in negative 0.0001 and square it. And we're going to put that over 4. And we're going to subtract 8 over negative 0.0001. And you can see, if I plug that in the calculator, so I do negative 0.001 and I square it, so I take it times itself, I get a positive number, right? I divide it by 4. Boom. Now I'm going to subtract 8 divided by negative 0.001. All of a sudden I get positive 80,000. So in the previous example, I got negative infinity, I got negative 80,000. This time I get positive 80,000. So what do you think is going to happen when I plug in the number that gave us the negative 8 million in the previous problem? Well, it's going to give us positive 8 million. So this limit is actually going towards infinity. Now I'm going to kind of skip down to the bottom here, and I want to do this limit yeah, let's do this limit first. So limit as x approaches 32, just because this one's a little bit easier than that one, so we can look at this one quickly. So we get 32 squared over 4 minus 8 over 32, and we can put that in the calculator. 32 squared divided by 4 minus 8 divided by 32. So I'm getting 255.75. So when I put that in the calculator, that's what that gives me. I could go ahead and put that as a decimal, I believe. Let's see, math fraction. That's 1,023 over 4. So this gives me 1,023 over 4 as a fraction. So as x approaches 32, I get this 1,023 over 4. That should make that should make sense, because that's kind of how we found limits in section 2.2. So same idea. This one though, this one's going to be slightly different. So the first thing I wanted to find, if I'm saying x approaches the cube root of 32, I'm really saying x approaches 32 to the 1/3 power. Remember, you can write cube roots as fractional exponents. So let's kind of start down this route, and we'll say, let's have 32 to the 1/3 squared, right, from our function, over 4, minus 8 over 32 to the 1/3. That's going to equal 32 to the 2/3 over 4 minus 8 over 32 to the 1/3. Now you can see 1/3 times, or if you square 1/3, that's how you get well, if you 1/3 to the second power is using the power property, we take 1/3 times 2, and that gives us the 2/3. That's how I got that. Now you can see 32 can be broken up into 8 and 4, which notice you got 4 on the bottom here. That's going to give us some power there. So let's kind of do that. We're going to break this up to 32 to the 2/3 is 4 to the 2/3, 8 to the 2/3, over 4 minus 8 over, and I'm going to break this one up to 4 and the 1/3, 8 and the 1/3. All right, if I take these and multiply these, I get my 32 to the 1/3 power. So then I'm going to write that here as equals 4 to the 2/3 minus 4 to the 1/3 is going to give us 4 to the, using exponent properties, negative 1/3. And then I'll have 8 to the 2/3. And that's going to be minus, if I take 8, subtract that, that's going to give us 8. Well, it's going to give us 8 to the 2/3, right? So that's going to be 8 to the 2/3 over 4 to the 1/3. Which I can then write that as, if I rewrite this negative is telling me I should put this on the bottom. That's going to give us 8 to the 2/3 over 4 to the 1/3 minus 8 to the 2/3 over 4 to the 1/3. So when I subtract those, well, they're the exact same. That's going to give us 0. So my limit as x approaches 32 to the 1/3 is 0.